Hi everyone, I am AysegulOzgenc Aksoy from DokuzEylul University, Izmir, Turkey. The title of my presentation is Experimental Comparison of Local Scour around Trunk Section of Rubble Mound Breakwater in case of broken and unbroken waves. First of all, I want to talk about the importance of the study. As you know, stability losses caused by the scour can lead to significant repairing cost increases in coastal structures such as breakwaters. So it makes the scour an important phenomenon. In this sense, our study aims to investigate the scour process around a trunk section of the Rubble Mound breakwater for both broken and unbroken wave cases experimentally. In my presentation, there are three parts, and first I will talk about experimental setup, then performed experiments, and finally discussion and conclusion. The experiments were carried out in a wave channel with a length of 33 meters and a width of 3.6 meters and a depth of 1.2 meters. At open sea part of the channel, there is a plunger type wave generator which was used to form regular waves with different heights and periods. To obtain broken wave, a ramp was located into the channel and the height of the ramp is 40 centimeters. Seabed material was placed into the sediment hole, as you see here, and Rubble Mound breakwater was placed on the seabed material, and at the end of the channel, you can see wave absorber constituted of rocks. The median size of the bed material was 1.85 millimeters. Two different measurement devices, ultrasonic level sensor and ultrasonic velocity profiler, were used in the experimental studies. These experiments work on the principle of high-frequency sound waves. Ultrasonic level system device and ultrasonic sound sensors were used to determine the characteristics of the regular waves produced by the wave generator. The sensors are positioned perpendicular to the bottom of the channel and do not enter the water. The sensors are connected to the main device and measure according to the sound wave principle. High-frequency sound waves are sent to the water surface by the sensors, then the sound waves reflected back to the sensors, and the vertical distance between the water surface and the tip of the sensor can be measured. Then the obtained measurements or the obtained values are transferred to the computer simultaneously. Another measurement tool is ultrasonic velocity profiler device and its integrated sensors. With the help of this device, which works based on the principle that high-frequency sound waves hit a moving particle in the liquid and return repeatedly, the flow velocities along the profile can be determined in any cross-section. And also, the ultrasonic velocity profiler device was also used to measure the bed material movements such as scour or deposition. You can see here the location of the measuring devices. 3 UVP transducer or sensors were used during the experiments, and one of them is for the velocity measurement and the other ones were used to measure the bed material movements around the breakwater. The ULS sensors, ultrasonic level sensors, were located on the channel, as you see here, and the distance between the sensors was 4.5 meters during the experiments. The results of 3 experiments were given in the study, and the features of the experiments are given in this table. During the experiments, a bed material which has 1.85 millimeters median diameter was used, and the surface slope was 1/1.75, and 3 different wave periods were selected. And you can see a maximum score depth that measured during the experiments for both broken and unbroken waves. And the duration of each experiment was approximately 1 hour. The temporal variation of the scar depth are given in these graphs. The numbers greater than 0 represent scar, while the number less than 0 represent deposition in these figures. And as you can see here, there is a significant difference between scar depths in the cases of broken and unbroken waves. So scar was observed around the breakwater for unbroken wave case, while deposition was observed in case of broken waves. And as a conclusion, in this experimental study, seabed material movements around the trunk section of a rubble mound breakwater were investigated, both broken and unbroken wave cases. The experiments were performed by using 3 different wave periods. The waves produced by the wave generator and were broken with the help of the ramp. Consequently, it was observed that score reduced significantly in the case of the broken wave. And I want to thank the Scientific and Technological Research Council of Turkey for supporting to this study. And you can see my contact informations, and thank you for listening. Have a good day.